let me introduce Mr. Mitsuhiro Kanada, the director of Arup Tokyo and a professor of Tokyo University of the Arts. Please welcome Mr. Kanada with a big applause.
Thank you. 안녕하세요. I'm already very impressed by the professionally organized event, organized by students. And I felt like I have to test it, right? So I asked them to change my slide like 3 minutes ago. And they have nicely done that. And the reason why I changed the slide is that I thought, maybe this is a little bit too serious. So I decided to put a quiz, this one. So these two slides, what is the structural similarity? How similar are they in terms of structure? Do you know this lady? Okay. Do you know him? Maybe not? Do you know who designed this? Gustave Eiffel of Eiffel Tower in Paris. So you can see that there's a structure inside which is very efficient because Eiffel used to be a bridge engineer. So that, I'm not going to dwell too much on that. And that's the inside of the replica of Gundam, because of course the real thing is not like, this ugly and bulky, but because this is a replica, there's a steel structure inside and the plastic finishing around it. So both of them, there are structures inside which is not what we see. So second question, how about these guys? What are the structural similarities? It's the opposite of question number one. What we see is the structure. The right-hand side is easy. That's a Formula One car. Everybody knows it's made of carbon reinforced plastic. And what we see, the form itself, is the structure. And there's a hole, and in the hole there's basically an engine and the driver. This one is a 1,300-year-old statue, Buddhist statue, and it's empty inside. Initially, they have sort of timber formwork, and they put the soil around it just to form a rough form. And on top of that, they have hemp cloth and with urushi, which is a tree resin. So it's like 1,300-year-old fiber reinforced composite. So there was a sort of similar thing, but we have of course a modern version of that used for car industry and airplane industry, but it's very difficult to recycle those oil-based material. So is there any way that we can sort of re-examine traditional materials which may be more suitable for our society today? So it's very difficult to ask for permission to structurally test the statue which has been there for 1,300 years. So we decided to make a sort of cylinder in a same construction or manufacturing method and structurally tested it. And that cylinder, which is about a size of Coke can, held about 1.5 to 2 tons, which is a weight of a car. So reasonably strong. So we decided to make a stool, and then something like that, no real use for it, purpose. And similarly, because it's a traditional craft, not just as a structure, but there's sort of a finished quality to it. So many structural materials like steel, concrete, of course concrete is sometimes exposed, but it requires architectural finish. Whereas traditional materials like timber or this urushi, it can cover the range from really big structure to like chopsticks or something that you use every day. What is this material? This is my last quiz. Anybody? Fiber? That's fiber, that's fabric. What about that?
Rubber?
Concrete. it's a concrete chair I made long time ago. Again, concrete, you have an image of sort of concrete finish on buildings, which is basically a copy of the formwork you use. Normally it's either steel or timber, but if you use, like for example, fabric, it appears something like that. If you use glass, the concrete comes out like a mirror. You can actually see a reflection of yourself in the concrete surface. So rather than coming up with completely new material, like super new material, just invented. Because in real architecture, we use a lot of quantity of materials, but that doesn't limit you. There's sort of a usual suspects like steel, concrete, timber, glass. Again, still, just the normal material like concrete here, it can still give you a different feeling, and it still gives you or your audience a surprise. But this, as a chair, is a failure because it looks very soft, but it's concrete. So if you are sitting there for a while, it destroys your clothes. So it wasn't sold as a product. But anyway, in the interview by a magazine, I was talking about this same thing about fastener in architecture. And a company called YKK, who produces a lot of fastener, read that and gave me a lot of fasteners for free. So with students, we came up with a way to use fastener as part of sort of pavilion in a way, so that it can be combined in any way and again relocated somewhere else. So I wasn't thinking in terms of sort of design for deconstruction, the theme of this year's, but it's something that if you think about the construction, automatically you're thinking about deconstruction as well. And of course, construction is hard enough, and now you have to think about deconstruction as well. And I think it's a very challenging theme and worth doing. So I'll skip through this one. Can you actually press the play button? This is again just using fastener. I thought it was quite interesting that deconstruction, right? And only thing I asked them to do is to think about the connection. And from there, they just took a liberty. And that was their connection sort of a piece. And obviously they enjoyed, right? But the design process or manufacturing process isn't easy. When we see a finished product like this, it looks like, oh, they must have fun. In the end, they did. But for, let's say, 90% of the semester they spent, they have been struggling, they have been sort of, trying and not working, and being questioned, etc. But in the end, because they stuck, really stuck to what they wanted to do, there was a breakthrough. And, the final product, I think, they're genius. Because during that sort of process, they persevered with sort of unworking ideas. And I think it's very important, not just for students, but for professionals as well, that your first idea probably wouldn't work. And if you're just designing on paper, or digitally, or just use scale model, you actually just don't notice that it doesn't work. But today, this pavilion, it's your chance to actually see that your design doesn't work first. And then in the process of making it work, your design will change, and let it change, because that's the real design process. It's not like you finish your design on paper and then hand it over to a manufacturer and forget about it. It's actually in that making process, there's a lot of design themes, design motifs that actually improve your design. Again, this is nothing special. Of course, helium, of course, it flows. What's interesting about this one is that it's about a meter cube helium balloon, and they're tied together. So individually they are separate, but they're tied together. And in order to sort of work against the wind, it's a little bit difficult to see, but there's some vertical elements that are thicker than the others. Most of them are just string holding it down so they don't fly away. But there's a carbon fiber ones which was just recycled, we were given. So that was stopping this balloon or group of balloons from swaying too far. And because it wasn't really designed for the wind, students were supposed to basically bring it down and tie them in the evening before they left. But usually wind doesn't come, and it's just a chore to bring it down individually, tie it, and come into the next morning and just untie it. So somebody actually didn't do it. And what happened was that, of course, when they don't do it, suddenly wind blows, right? And it was broken. So that's the part, that what sticks out is the sort of sway preventing one, and that was all broken. Of course, we can just cry and give up, but what we've done is that, okay, now it's broken, so the FRP sticks that we were given is now shorter. So let's reduce the ceiling height. And compared to what we had initially, it was much higher, but now it's lower. And the behavior of people underneath changed. Before, people can actually pass through, and now it's much lower. So it's actually, if you're an adult, it sort of hits your head. So suddenly it became a paradise for kids and their mothers. And so the ceiling height, of course, there's always a discussion. What's the minimum architectural element? Is it a wall or is it a roof? And this one sort of gives a hint. What does that do to have something above your head and the height? For example, if that roof is this ceiling height or very low, the activities will inevitably change. So I think a pavilion, something light, something that you test, you build and test. You can test many things, not just how it stands up or how it gets constructed or deconstructed, but how do people react to your design or construction. And you can sort of test that. So that's the beauty of a one-to-one mock-up, one-to-one scale element, that it is architecture, you can test. So it's like a full-scale model. So that was pre-lecture. I just wanted to put that in. And because I thought my lecture was a little bit too serious too. Well, not that serious to be honest. But the title Socially Sustainable Architecture, because of course sustainability is everywhere now. In the school, in the actual professional industry. And in a way, it's sort of material sustainability, carbon footprint, embodied carbon, it's all very important. But you as students, you don't have to sort of calculate, okay, what's the embodied carbon and, judge your design. You're still learning the design, right? So important thing is that, is it socially sustainable? If you don't enjoy it, it's not socially sustainable. If people who use your pavilion, who visit your pavilion don't like it, then that's not sustainable. So it's not just sort of material, carbon, or numbers, but it's actually how people react to your design. And today I cannot explain everything, but just a few examples. Okay, this is a library with Toyo Ito. I'm sure that Ito-san will come sometime this fall. Hopefully, he can talk to you guys. He's one of the tutors. So, and this is for Expo in Milan for Japan Pavilion. This facade, this timber facade, was dismantled and used in many different parks and squares in Italy. So it has a second life. So it's just as a hint for your pavilion that after dismantling, it doesn't have to be exactly the same thing. It can be parts in many different areas. Again, this one is with So Fujimoto. this initially, or from beginning, was conceived that after initial usage, that this timber will go into sort of second use. That's why that we didn't cut it, or we had a minimum intervention in terms of connection, so that it has a second life. This one is sort of a more literal transformation. Sort of, there was bolt joints in order to bring it in terms of transport and connect them on site, and again, sort of take out the bolts and it goes to other place. So this one is more direct construction, dismantling, and reconstruction somewhere else. So there are many ways to think about your initial construction and deconstruction. And when you deconstruct, where does it go? How does that get used? Is it going to be in one piece? Is it going to be in many pieces? Or is it going to be something completely different? Or is it going to be combined with your, other universities? There are many universities, right? So maybe you can combine 2 or 3 to come up with something completely different. So there are many ways to deconstruct and design for the second life. This one is my most sort of recent project. And when I was designing this, I was thinking about showing you guys today. And it made just in time. It's designed by Ryue Nishizawa of Sana. And it's sort of a temporary pavilion. It was used only for 3 days. And the project started only about 2 months ago. So you have actually longer time than them or me. And I was actually in the middle of giving an entrance exam to high school students coming into our university. So when I was asked to have a meeting, I said, no, I can't. I'm doing the entrance exam. But they said, you have a lunchtime, right? And there's, campus is closed, you cannot come in. They said, but you can come out. So this is like a nearby cafe, and I saw the urgency, and it's basically they had only 2 months to design and build a pavilion, like 12 meter in the 12 meter by 12 meter. And I usually don't say no. I usually don't say it's not possible. But this one was closest to being impossible. So, they're still thinking about the design. It's not like they had a fixed design. The first thing was like, what do you think? And my reply was, do you have a manufacturer? Because we can design, but if there's no people to build it, there's no point. So that's March 9th. That's something you start your design with, right? So famous architect saying, nothing special. And a month later, so April 10th, we were at the fabricator. So there's a timber specialist, and of course the model is now a little bit more advanced, that structurally engineered and also designed. But important thing was for me to actually feel the material. It's not, of course, these days people think, oh, everything can be, calculated, analyzed with FEM. Yes, of course, it's possible to analyze, but particularly when things become small, when it is really affected by the craftsmanship, you really need to see the material. You really need to feel it. Do you see how sort of bouncy it is? Is it good enough or not good enough? It's hard to judge, but when I actually felt it, I was quite confident that this works. But just by calculating and knowing what's the deflection, it's very difficult to have a physical sense. And I trusted this guy. This guy said, I'll make it, the entire thing. And this type of sort of collaborative network, you have, for example, how do you connect timber to timber? Of course, you have an idea, but he's the one who actually does it, and you talk to him, and see what's the best in terms of reliability, in terms of the speed, etc. And May 1st, it was on site already. And the guy was here, traveled with his staff, and connection was made very simple so that it can be dismantled. And I think at this stage that I asked them to take out all the scaffolding supporting them, and I went on, and I just shook the entire thing. And then I felt okay. It's very, in a way primitive. We done all the structural analysis to make sure that it works, but in the end, you really need to have a gut feeling that it works. And this is already a few days later, it's getting dismantled piece by piece. And because it's light, this time they decided not to have a scaffolding, just do it from the top down. And each piece is kept and documented, because no matter what you do, once you use for real thing, it'll be damaged. So don't assume that you can use the same material again because it's the same. Of course, you can use steel and bolt, and it's much easier to sort of rebuild. But it's important to think about what's the afterlife and what's the capacity of element. And for example, if we rebuild this, those timber coming together, the connection, right? Next time it won't align, it will be somewhere else, right? So it's quite different from what you design on paper. You cannot tell who's the architect and who's the contractor, right? He's an architect, he's a contractor. But they are working together. And on site, it actually almost doesn't really matter. And they are now discussing, okay, for the next rebuild, how much do we disassemble? For example, do we take steel steel element away from timber because it may damage further in the warehouse? That kind of stuff they are talking about. I'm sorry, I don't really speak Korean, and I wish I did. But in Japanese, the word to build or to make and to maintain has the same origin. And I'm just wondering if some word in Korean has something like that, sort of make and maintain or repair or something like that. Because our tradition in Asia, that buildings were in timber, many buildings were in timber, right? And timber buildings deteriorate very, very quickly. It's not like a pyramid. You cannot just leave it for 100 years and assume it's there. So the moment you finished your building, you need to sort of look after your building. So it's continuous building, continuous effort to keep it up. And I think that's the important aspect of today's building. Of course, in the modern age, that we are requested or required to design something which is maintenance free or low maintenance. But low maintenance building is not loved. Low maintenance building is just ignored. It's just not a problem, but it's not loved. One example I'd like to show is in an island called Teshima. Now it's quite famous for Ryu Nishizawa's Teshima Art Museum. But before the Setouchi Art Biennale came, it was actually known for like a garbage dumping island. So there's no tourists coming, and there's no restaurant on the island. But because they had an art event, they knew that tourists are coming, so they wanted to have a restaurant. I'll skip that. Teshima is here between Osaka and Fukuoka. So that's the Teshima Art Museum. If you haven't been there, it's one of the best buildings I've ever been recommended. And that's how Teshima looks like. That's the site. And there was an abandoned sort of area, persimmon trees, and that was our site. So that was not used, so we changed that into a kitchen, and we wanted to have an outdoor sort of eating space, and we didn't have any budget, so they said, okay, as long as you can provide sunshade, it's okay if the water leaks. So that's the plan. I'll skip that through. So that's the persimmon trees we wanted to preserve. That's the abandoned house now turned into a kitchen and a little bit of eating area. So that's the part we wanted to, what we were asked to make. That's the plan. And when you actually don't have much money and also no contractor on the island, we decided to take students to the island and build it ourselves with the people of the island. So because there's no contractor, we decided to use water pipe as our structure, because water pipe is very easy to use material. About A3 printer size machine will cut and thread at the same time. So you can have actually a threaded end to it. And you can go to hardware store and buy a sort of water pipe connections. So my students went to hardware store and bought like 50 different types of water pipe connections. And we went to the site, and so that's just a car, and that's the machine to cut the end of the water pipe, or just cut the water pipe to the length and thread them. And so that's the sort of typical connections that the student came up with. That's the construction, very simple. Also water pipe and a reinforcement bar. And that's just a shingle, like a cedar shingle, sort of given by one of the sort of the father of our students. They were, he was living nearby, so they gave us this shingle put up by students. And this was designed and actually had a permit for 3 weeks just for the art event. So, for 3 weeks we thought, okay, just tying with, plastic, that should be fine. So that's how it gets finished. It provides sunshade, but it leaks like hell. When it starts raining, rain goes through. An important part of the story is that this restaurant is maintained by the neighbors. So they are sort of neighbors, who said that they will look after the kitchen. And he is a chef from Tokyo who was there just for first months maybe to develop a menu with those old ladies. And this became like extremely popular place with tourists, but also with local communities. And because it had a permit only for 3 weeks, I had the sort of a duty to say, well, this is only temporary. Should we take it down? And they said no. Then what they've done was that it's actually ingenious. As I said, if you don't look after timber buildings, they just deteriorate very, very quickly. That's what the people of the island decided to do. They took the timber down, and they said, the structure you designed doesn't exist anymore. The building that had 3-week permit disappeared. And they put back new timber. And so there's a student volunteer and the local community people. So that reappeared without architect, without engineer, just by local people. And every time this sort of gets deteriorated, they do that. So it's now completely owned by the community, and the community decides when to sort of upgrade. And this is now, I don't have to look after it. In fact, I cannot look after it, but it is super high maintenance. Every 2-3 years they have to actually redo the roof. But by doing so, they are saying, oh, it's a temporary structure. It's our temporary structure. And because they love it so much, I'm quite certain that this will last very, very long time. And it's not because it's very robust. It's very using robust sort of maintenance-free material, but because people love it. So that's a success story, and not always I succeed. So this is another very interesting project I wanted to share with you, is that after Tohoku earthquake and tsunami, the outside of this aquarium also had basically tsunami disaster sort of around so the building itself was okay, but the outside landscape was completely destroyed. So again, students and many volunteers built this sort of entrance tunnel. The idea came from a landscape architect, and who came to me and said, I'd like to use kuzu. Kuzu is like a vine, a type of vine, and vine is very weak in the beginning, but it actually becomes like a tree. It basically becomes very strong. So he said, just have a bamboo as the guide, and the vine will become strong. And I asked, how long does it take? He said, 20 years. Well, bamboo doesn't last 20 years. Bamboo probably doesn't last even 3 years. And he said, oh, that's okay, because we have high school students who have nothing to do. We will come and repair. And at first, I didn't think that was a good idea. But I came to realize that because it's a remote place, that there's no university, so all the high school students either get jobs locally or go to university in either in Tokyo or Sendai, some remote place. So when they come back, they come to check whether the part they patched still exists, or if still exists in the entirety. So we cut the bamboo and created this. It's like a fast year. But if it's not very well maintained, the vine actually took over, and in a way too much. And because we didn't have a sort of a social mechanism to maintain this, it was basically became too much. And after 10 years, it was demolished. So similarly, this was high maintenance building, but because it wasn't like the previous example, it wasn't sort of owned by the community. Again, it's not just the design quality or the material, but how you sort of socially set it up, which I learned quite, in a hard way, that there's a huge difference in just designing or just stepping in and really work with the community. Okay, this is more of a permanent building, so it actually there's no deconstruction story to it. That's how inside looks. It's a timber structure roof. It was a competition in 2010, and when I was asked by Mr. Ito, he had a sketch or concept like this, and his concept was large house and small house. So there's a large house, and there's a sort of small house with sort of diverse characteristics. That hasn't changed, but actual sort of appearance has quite significantly changed. And I think that's the fun part of designing in collaboration. So that's November 26. I usually don't take these things too seriously, because you'll be surprised that only 10 days later it completely changes. And you need to go with that speed, and you also need to influence that change. He was saying that, okay, in order to see the other side, the small house now is hanging from the large house. And in order to win the competition, maybe it's better to have a simple flat structure because then it looks cheaper to the jury. But the natural ventilation was very important for this project, natural ventilation and also bringing in the light from above. And sustainability, the consultant who with me said, if you actually want to take out the light here, you want to have a height difference between the low part and high part. And then, of course, Ito-san didn't want to have a flat ceiling. He thought that he doesn't have a good reason to have undulating form. So he was quite happy to go back to some sort of a free-form roof. And then he started asking, is it concrete? Is it steel? Is it timber? I've worked with him. We've done concrete in Taichung. We've done steel. So I said, why not timber this time? And these are made by my students and studying, what's the, best grid, both structurally and also to bring the light in. Again, this is also sort of going against the current sort of modern way of building. Modern way of building is to make as large unit as possible in a factory, in a very controlled environment, and bring it to the site and connect them together. Here, I propose that, okay, let's do the other way. That let's bring in very small elements and build on site. Because if you are going for large elements, that means only large companies can do it. And I wanted, because Gifu, this area, has a history or tradition of good carpenters, so I wanted to have a lot of carpenters involved here. So the element itself is something that you use for wood deck, so 20 mil in sort of depths and 120 mil. So you have outside of your house or something like that, and brought in. So that's my connection detail. Again, that's my student. I think he had too much of model making that he decided not to go into architecture, but he became a Honda's car designer. And when architecture and structure is married, of course, we need to make a joint decision, right? So both structurally and engineering-wise, probably not the square grid, but triangular grid is better. And that's about 450, that's 900. And Ito-san says structure, design was 450 is good. 900 was the lightest structurally. So we thought, okay, we probably will settle on 600. But he said, no, let's go with 450. So what do you do? But it's true, 450 is beautiful. So what the reasoning I had was that the top and bottom, where is the most efficient, like if you think of I-beam, the steel is at the top and bottom, where it's the most efficient, is 450. In between is 900. But when you see, for example here, so 450 is just one layer and there's nothing behind, but you really see 450 great pattern. And it's not pre-bent, it's just brought in as a straight element. But if it gets long enough, it's because it's basically flexible enough that you can bend and twist quite easily. One of the nice things about being in the construction sort of industry, whether architect or engineer or contractor, is that you can see, these things getting built, which is beautiful. This is the photo I wanted to show of this entire project. Is that's about 150 carpenters all together on top of a roof, building this timber roof together. That's Ito-san, Toyo Ito, architects team, engineering team, that's me. And it was first time to see that carpenters coming to an architect and asking for autograph on their helmet. So there are a lot of carpenters walking around with Toyo Ito's name on their helmets, like, everybody's Toyo Ito. And on the completion day, on the opening day, I was really, really glad to see that, these guys came with their family and say, well, I built this. This is my, library. And I think the successful project has many people saying this is mine. Like I'm saying this is mine, but all the carpenters saying, oh, I built this. This is mine. And because they live nearby, they are the supporters of this building. And this one is not actually designed for deconstruction, but this one has the community of supporters for this building. And I think that's a very important part of sustainable architecture, that it's not about just the numbers that you calculate, but like socially, how is it loved? How is it really owned by the community? I think that's very important. So, designing for deconstruction. Deconstruction in 2 days, like the one, 2-3 days, like the one I showed with Ryu Nishizawa, just a very recent project, or 2 decades, 2 centuries, it doesn't really matter. It will be deconstructed sometime. But just focus on people, focus on sort of human side of sustainability. And most importantly, you should enjoy it. If you don't enjoy it, I don't think it's sustainable at all. And enjoy designing, but also enjoy making. It's frustrating. I guarantee you it's very frustrating because it's not gonna success. It's not going to be success at first, but just keep at it, until you succeed. Because then that jump, if you experience that jump of having a trouble in real scale and solving it to see that you are, actual building, no matter how big or small, that you get hooked to this profession. That joy of making things. I think you're in a wonderful profession. 감사합니다.